What?
It's equal in magnitude, opposite in direction.
Fe equals.
No, you already found it, Fe.
Where?
F equal to FG. Because there's.
Oh, it's suspended! Dear God.
Today we're going to go over physics test number 16. We have two students, one from Brown University. Brown is an Ivy League university.
No, it's not. Ground on the ground. Taught just like dirt.
Look at your father. Face the reality. Is Stony Brook an Ivy League?
It's an Ivy League. Everything you ever wanted in life. High cost. Paying off student loan for the rest of your life. Getting made fun of.
Is it an Ivy League?
Is it worth it to go to an Ivy League? That's the question I want to ask you today, sir. We're pulling it with 100 newtons northeast at a 40-degree angle, WRT horizontal. Find the mass of the box and round to the nearest whole number.
Applied force is 100 Newton. Isaac is pulling 100 Newton by 40 degree. I don't know why he decided to pull with 40 degree, not 0 degree.
Maybe he's pulling it up an incline.
Wood, and this is also wood.
It's not an incline?
Quickly, I'm gonna ask you do a few things. Let's see who can give me this faster. FAX.
76.6.
This is 77 to me. Let me see who can give me this one faster.
64.2. 64.3.
64 to me. Let me see who can give this one faster.
77.
Okay, good. You are scoring by giving me the answer. Let me see who can give me the normal force faster.
255.3.
You don't know that.
How did you
calculate?
What
right.
is the equation for normal force?
It's equal to FF over mu. So it's 77 over 0.3, which is 257.
257.
How do you get 255?
Let me see who can give me the weight faster.
257.
Not 257.
No,
sorry.
it's
sorry.
320.
320. 320 Newton. Okay, good. Let's see who the ultimate goal is to find mass. Let me see who can give me Newton's second law faster.
F equals ma, so
In this
33
case, it's not F equal
kilograms.
ma.
F equals mg.
Okay.
It's the same thing.
So, m is equal to
32.6. Or 33.
I disagree. 32.7.
Okay, both of you wrong because it's 32. I decided to use 10.
Stuck in a boat in the middle of a lake. Luckily, you brought your physics book. You decide to use your book to propel yourself back to the shore. You throw your 1 kilogram book overboard with a speed of 10 meters per second to propel yourself back towards the shore. Assume the combined mass of you and the boat is 100 kilograms. The shore is 60 meters away. Unfortunately, it starts raining as you float toward the shore. The rain falls straight down to the boat. 10 kilograms of rainwater has accumulated in the bottom of your boat in a very short amount of time. Find your velocity.
Reading the book.
Wait, why would you need the distance from the shore?
To distract you, to distract people like you.
You're very naughty.
It is true. And all of a sudden, it started raining, and water all of a sudden outside and inside. And then Isaac got nervous. And when he nervous, you know what he does? He break the pedal. Okay, so no pedal broke. Isaac is in the middle of the sea, I don't know, middle of the river. He doesn't know swimming. Sad. The guy doesn't know how to swim. Now, of course, he's a physics genius. If you are a physics genius, then you don't need to swim. He gonna throw his beloved physics book. So that's probably the after. After he is here, and the water is inside and outside, of course. And his physics book is here, 10 meters per second. All right. Now, can you tell me the boat and water? Boat.
It's 100.
Isaac. And water.
It's 110.
110 kilogram.
How long?
Book.
It's 1 kilogram.
1 kilogram. All right, so I'm gonna write
By
m
conservation of momentum,
momentum
the book
before.
has 10 kilogram meter per second.
So m1 v1 plus
so that means
m2
that
v2.
v1 is 0.
That means the boat, Isaac, and water is 0.
And v2 is minus 10.
B2 is
minus
0. It's because everything is at rest.
Oh, you're right.
Right. Okay. V1 is?
V1 is now what we're trying to find.
Okay, good. So 110 V1 prime plus 1
minus 10.
10. So it's probably V1 prime is equal to minus, right?
Yeah.
10 over 110. And that is?
Minus 1 over 11.
0.09.
It's actually 0.091.
The sound though.
It's 0.091.
Is it west or east?
What? Well,
west.
No, it's east.
It can't be.
The book is moving to east, so Isaac is moving to the west.
Oh, I didn't see that part. I only saw that.
Yeah.
So everything.
Okay.
Mamma mia. The vertical height gained by the box is 10 meters.
Is gravity help you, or you have to work against gravity?
Against gravity.
How much?
Hey, isn't the answer 80 newtons?
Okay. How long you pulling the box for? And how high it is?
10 meters.
All right. So please answer those questions. This is a police investigation, kind of a FBI
Is
investigation.
it not 80 newtons?
Okay, hold on. You are finding F and F. Please don't jump ahead. Only people who have things to hide, they jump ahead.
What?
Okay.
Sound like both problems.
Yeah. Okay. Good. Number 1. How do you know there is a friction? You don't. Only way you know there is a friction is potential energy top is equal to work done by applied force.
The only way you know there is...
If potential energy on the top is less than work done by applied force, then there is a friction, and that's what you're going to find.
And if it's greater, then something has gone wrong, and you need to check your work, because you've done stuff.
So, everybody, potential energy on the top, let's see who can give me faster.
It's...
600. Oh.
Sorry for you guys.
I said 1,000.
Oh, you did?
Yeah.
Work done by applied force is, that's what we're going to try to find. Work done by applied force is FD cosine theta, right? F applied. Now, Isaac, I'm going to ask you a few questions like FBI.
What?
I have a 2 vector. One is red, other one is black, right? What is the name of the red vector?
Displacement?
Sure. What is the name of that black vector?
Work? No, force.
What type of force is it?
It's applied.
Okay. What is the angle between red and black?
0.
Okay, good. That's right. Cosine 0. And do you know, without using calculator, cosine 0 degree is?
0.
What?
No, 1!
Oh, you're measuring in that.
Congratulations.
I was just making sure.
Tell me the top right.
Don't say you got qualified in math Olympiad.
Come on!
Yeah, that's right.
tired.
It's small mistake. Okay.
I'm also tired.
Yeah. All right. Yeah. FA is what?
80.
80. And D is?
20.
20. So this is 1600. 1600 joule, right? So what do you see? Is there any friction?
No.
Yeah. There is a friction because.
Oh yeah, 600 joules were lost.
Yeah. So potential energy on the top is not equal to.
Work done by the applied force.
So then we have to find the work done by friction.
I'm gonna guess that.
Can you give me the equation?
It's 30 newtons. 30
No. Give me equation.
FD.
WA minus PE.
WA minus P.
Well, obviously. We're
Or
trying to find the force of friction. So
what is WA? 1600
1600
minus?
1000.
Okay.
Let's see if Refast can do this arithmetic.
Okay, I said before. Okay, all right. Now from WF to FF, I want equation because I'm an equation guy.
WF equals FFD.
Oh, okay. WF is equal to FFD, which is wrong. I'm sorry.
But theta is just 180 degrees.
Oh, okay. Yeah, that's right. It is 180 degrees.
Now just reduce it to minus.
Because
that's a trivial science.
because now red is
You thought it was 0 degrees. Then
now-
you idiot.
now red is D.
Loser.
Red is D and black is Red is D and black is
Force of friction.
FF. Okay. Now WF is equal to what?
Bro has that neck beard.
FF D minus. Okay. So then FF is minus WF over D. So WF is how much?
600.
You can do it.
And D is
40.
so is negative
30.
30.
Yeah,
Newton.
you can do basic.
Spring constant of 2600 Newton meter is compressed 0.1 meters from its unstretched position. The spring is released, propelling a 3 kilogram block along a horizontal frictionless surface. This block then collides with a stationary 1 kilogram block.
A 3 kilogram mass held against what?
The spring.
A spring and held against it by a block and waiting to collide with 1 kilogram, right?
Yeah.
Okay.
No one can see me if I sit back.
No.
And then this is before and after. Can you tell me what is happened after 1 kilogram?
They stick together, meaning it's 4 kilograms.
So can you tell me what type of collision is this?
It's inelastic.
Inelastic. Why inelastic?
You have to shut up.
They stick together completely.
Because kinetic energy lost, not because they stick together.
And that is exactly why my first solution is incorrect.
Okay, so number 1 and number 2, whose equation is right? M1V1 plus M2V2 is equal to M1V1 prime plus M2V2 prime, or M1V1 plus M2V2 is equal to VM1 plus M2, because 2 agrees with the diagram. Okay, good. Now, this guy has a potential energy or kinetic energy?
Potential.
How much? Half kx square, right?
Yeah.
So P is equal to 2600 point. This is compressed 0.1, right?
Yeah.
0.1 square. So 1300. So potential energy is equal to 1300 times 0.01, which is 13. Is that right?
Yeah.
Good. Now this become the kinetic energy, right?
Yeah.
So then what happened? Half mv squared is equal to 13. And then
M is 3.
so mv squared is 26. So v squared is 26 over 3. So v is 3, more or less.
3?
Yeah.
More or less. Okay, so m is how much?
M
M1
is
is 3.
3.
M1 is 3.
And v1?
3.
M2?
1 and
0.
0.
Good. Is
And
equal to?
V prime
V prime
times 4.
4. Okay. V prime is equal to
9
over 4, which is 2.2. More or less, approximately.
Oh, units.
Oh, units, meter per second.
Each of the 4 vectors and find their magnitude. Or maybe I should do it over here. So this is FG.
No, do it outside and big.
Okay.
No, do it outside.
Outside.
Electric field.
4 vector outside and then magnitude.
1 second. I'm pretty sure it goes from positive to negative, right? So no, that's the electric field. G? What is G?
G field.
Oh my god.
The gravitational field.
Oh, that's not the same thing as F. Okay. So it wouldn't just be this.
Yeah. Why it's so difficult?
Oh, we have to find the
One
magnitude.
of my students draws G is up. Then I said, then you're gonna go to heaven. If G is up. What's keeping you down is G. So why you put G up?
Heaven or hell? Okay.
And the student reply was, oh.
Oh, God.
Put the notation of the one that you're finding.
This is FG. And then
What are you doing? Fg is equal to mg. M is electron.
oh,
Jesus Christ.
I may or may not have tried using the universal law of gravitation. Times that. Hey! Soon, the magnitude of the electric field, 1 coulomb, 6 to the what?
It's equal in magnitude, opposite in direction.
Fe equals.
No, you already found it, Fe.
Where?
F equal to Fg. Because there's.
Oh! It's suspended! Dear God.
Can you circle the direct?
Yeah.
Which one is Fg? Which one is G? Fast G. Fg. E. Fe.
I'm desperate, guys. I'm desperate.
No, you're just wrong.
How? How is this wrong? Just tell me.
If I told you, then there's no problem.
Okay, fine.
Oh, what is the mass of it?
9.1 times 10 to the minus 31, sucker.
I don't know what you're doing.
Alright, so this is.
What did you get 8.92?
What units are these? Newtons per coulomb, right?
A force of 10 newtons towards the right is exerted on a wooden crate moving to the right on a horizontal wooden floor. The crate weighs 25 newtons. Find the acceleration.
Isaac, can you tell me FF?
Oh, 25 newtons.
Mu Fn.
Okay, FF is mu Fn.
And that would be 7.5 newtons.
7.5 Newton.
Which
Isaac,
would make the total force 2.5 newtons, which would make the acceleration 0.1 meters per second squared.
2.5 divided by?
2.5.
Where did the 2.5 come from?
10 minus 7.
10 minus 7.5. And mass, where the mass come from?
2.5.
Where does it come from?
25 over 10.
So acceleration is 1 meter per second squared. Any question?
Field exerts an electrostatic force of magnitude 1.5 times 10 to the minus 14 newtons by a source charge of 10 coulombs on an electron 980 meters away from the source charge? What is the magnitude of the electric field strength at the location of the electron?
What is the name of this one?
An electron?
What is the name of this one again?
Source charge.
Oh, I see.
What is the name of this one?
That's an electron.
What is the name of this one again?
Test charge.
Test charge.
You're right.
Test charge can be negative too. What is the distance? R.
980. You sure you didn't forget a decimal point or anything?
No, it's fine. Okay, and what is the name of this one? Please tell me, Isaac. What is the name of this line?
That's the displacement. That's distance.
Try again.
What? Oh, that's the force?
Try again.
What? The electrostatic force.
No, electric
The
field.
electric field, okay.
Yes, this is given over here is, by the way, the direction of the force. Isaac, can you tell me what is the direction of the force?
The
Predict.
direction of the force?
Yeah.
Well, if that's positive 10 coulombs,
Yeah,
then the force should be towards the source charge.
good. This is force.
Wow, you got it right.
Rifat, please don't do this.
How much is this one force?
1.5
times
times
10
10 to the minus 14.
Minus 14 Newton. Okay. I'm going to ask you give me two equations to find the E.
What? I can't?
We are finding E.
Yeah, but to find F, you need...
K.
Oh, right.
K.
Q over R.
R squared.
R squared?
Right.
Oh, I see. Isn't that the exact same thing, though?
Exact same thing of what?
Exact same equation?
Of what? F is equal to K Q. Q over R squared.
Yeah, those are the same equation.
How? It's the same.
No, like E equals F over Q and E equals...
That's true. Okay. So what is this one? K is 9 times 10 raised to 9. Q is
10.
10 and R is 980 squared. And this is
Okay, I got it.
1.5 times 10 raised to negative 14 divided by 1.6 times 10 raised to negative 19. So
They should agree with each other.
yeah,
Okay, this one is 93710.
9 times 10 raised to 4. Also 9 times 10 raised to 4. Internal column.
It's placed in an electric field of 50,000 newtons per coulomb directed upwards. What-
Directed upward. Hold on. Directed upward. Okay.
What
So
mass
then positive is here, right?
Uh-huh.
And this is negative, right?
Uh-huh.
So then this is electric field. Electric field is how much?
50,000 newtons per coulomb.
Okay. What do we need to find?
The
mass.
mass of
So
the
that
charge
it
so
stays
that it stays
suspended in the
suspended.
air.
Okay, Isaac, help me out.
So in other words, this is
This is
FG and the other one is FE.
so F.
So
G.
FE is equal to E over Q.
FG is mg.
So mg equals E over Q.
E over
No, EQ.
No.
E times Q.
EQ. Yeah.
Please read off. Shut up.
Okay.
You got it wrong.
You don't have to look at me like.
Okay. M is equal to EQ over G. So M is equal to E is how much?
E is 50,000 or 5 times 10 to the 4.
Times Q is
5 times 10 to the 1.
Q is
Q is 5 times 10 to the minus 5. I'm sorry.
Q is
50 microcoulombs,
oh
which is 5 times 10 to the
raised to
minus 5.
That's true. And Z is 10.
Wow!
That is right.
10 to the 1 times 10 to the minus 6 is 10 to the minus 5. Mind blowing, right? Right? Idiots.
25
2.5 over 10.
times
10 to the minus 1.
10 to the
It's 0.25.
minus 6, negative 2. So 0.25 kilogram. Okay.
Charge Q1 equals 7 microcoulombs is at the origin. Charge Q2 is equal to minus 5 microcoulombs.
7 microcoulomb.
Yeah, at the origin. Q2 equals minus 5 microcoulombs on the x-axis, 0.3 meters from the origin. Find the magnitude and direction of the electric field at point P, which is 0.4 meters at the above, and find the magnitude and direction of the electric force on a charge of 2 times 10 to the minus 8 coulombs, placed at P.
Over R squared.
Oh, right.
So E1 is 9 times 10 raised to 9. Q1 is
7 times 10 to the minus 6 over 16 times 10 to the minus 2. So then you get 10 to the.
Okay, I got it.
okay. Is it 800,000?
393,700.
394,100,000. Okay, good. Is that right?
That's what I get. Yeah.
Okay, good. Newton Coulomb. E2 K Q2 over R squared. Let's see who can do it math quickly in the
But
head.
I don't even have a calculator.
Oh no, this is not calculator thing.
Oh.
5 times.
Because you use the calculator.
So 9 times 5 divided by 0.25 times 10 raised to 3. 45 divided by 0.25.
That's 104. No.
So that's
That's 180. That's 180.
180,000.
180,000. Wait, but I get.
All right. No calculator. Okay.
no.
Who can tell me this angle quickly?
That's 63. I think.
No.
Yeah, that's.
I think you need calculator to find the angle.
It is 63.
No.
For E2, what radius did you plug in? 0.3 or 0.5?
That angle is 63.
Or 0.5? Oh.
No. Tell me what angle is this? 63?
Yeah.
Can you double check?
No, let's do the math.
Yeah. All right. Let's do the math.
Yeah, I don't want it.
I know you're slow.
Okay.
Come on.
Sokatua.
So this angle is the same as this angle, and this angle is just equal to.
This should be not 63.
Yeah, I'll show you. Jeez, it's 63. Tan theta is equal to opposite over adjacent. So theta equals arctan 0.4 over 3, which is 63. I'll show you right now, in fact. And let me just set this to degree. Yep, it's already degreed. Tan minus 104 over 3. Okay, you're right.
That's what I've been saying.
Okay.
Okay. So you should not rely on your common sense. Math is more important than common sense. Okay, but don't be embarrassed. Tell me this vector.
E1.
E1.
You said E13. It's just E1.
Can you tell me this vector?
That's E2.
Let's see who can tell me this angle quickly.
143.
Yeah, he's right.
143.
Uh,
Okay.
Can you please not laugh?
Can you now? Can you? Let's see who can do it by without calculator. So you have R is equal to.
How are we supposed to calculate now without a? Oh, don't you dare!
A squared. A squared plus.
I'm not letting
B squared plus 2AB cosine 143. So R is equal to 394,000 square plus 180,000 square plus 2 394,180 cosine 143.
Squared plus 2 times 394,000 times 180,000.
Cosine 143, don't forget.
Cosine 143, don't forget. 273,000. 100-kilogram object is placed 1 Earth radius above the surface of the Earth. What is the gravitational field at that location?
So to find the gravitational field, 1 Earth radius above the Earth. First of all, what is the radius of the Earth? Well, let's call it R. Now, if you're 1 Earth radius above the Earth, then how much is that from the center of the Earth? That's 2R, right? So remember that Newton's universal law of gravitation tells us the force of gravity is gm over r squared. Now, if you want to find the gravitational force, the gravitational field, set this equal to the force of gravity near the Earth, so that you find the gravitational field G at some radius r from the Earth is gm over r squared. Now we know, of course, at the surface that this is about 10, right? Now, if you are 2r away, then what is the gravitational field? Well, just replace r with 2r. And what do you get? You get gm over 4r squared. Now, if you compare this one and this one, you see that this one is 1/4 of this one. So 1/4 of 10 is about 2.7, I guess, or 2.5, something like this.